All right, good morning, guys, once again. So what we are going to be doing today is that last assignment, which is called Inscribed Angles right here. And we're going to go into Khan Academy. We're going to have to click like next like 16 times. So once, twice,
Where are you there?
3, 4, 5, 6, 7, 8, 9. And it does that sometimes. 9, 10, 11, 12, 13, 14, 15, and 16. And we're looking for inscribed angles. I'm sorry. I am in the wrong class. I am in calculus right now. Sorry. I need to do that again.
Oh, how dare you?
Exactly.
It's okay. We
So
all
one,
make mistakes.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So we're looking for inscribed angles, and it is this guy right here. Okay?
Got it.
So actually, in I think maybe 2 weeks ago, for the enrichment problems, okay, we've gone over how to we've gone over this theorem where like at least proving what that theorem was. Okay, do you guys recall seeing this or hearing about it?
Maybe I don't really recall.
I don't know.
You don't recall? Okay, if not, that's okay, because I'm going to remind you, okay? So I'm going to jump on my tablet here. The inscribed angle, and what exactly is an inscribed angle? An inscribed angle is an angle that's formed by 2 chords. It's an angle that's formed by 2 chords. And so I can see here, just to differentiate a little bit, right? There are 2 different angles here. Do you guys notice what I'm pointing at right now? What is this angle called?
Theta.
That is true, but there is a general like name that this angle is called. Starts with the letter C.
Central angle.
That is the central angle. Okay, so a central angle, okay, is an angle formed by 2 radii, right? So it's formed by these 2 radii. The inscribed angle is an angle formed by 2 chords, which is this guy right here. This is the inscribed angle. Okay, so there was a relationship, okay, that I had shown you, and there were like 3 parts, okay, to one of the enrichment problems that we had done, I think 2 weeks ago. And that was, well, what happens, okay, what's the relationship between this inscribed angle here and the central angle? And moreover, what is the relationship between the inscribed angle and that intercepted arc? As it turns out, this inscribed angle is going to be half of that of the central angle. Okay, so one more time, this inscribed angle is going to be half of this. I'm going to jump over to my tablet, and I'm going to do a quick review of that theorem, of the inscribed angle theorem. So I'm going to present screen.
Are there only 4 people on right now? Where's Michael?
Say that again, I'm sorry.
Huh, that's weird.
Okay, so I'm going to present screen.
My grid isn't working.
Okay. So we have this. I'm going to turn on the grid. Whoops. So we have a circle, okay, and as it turns out, okay, the way in which we can draw an inscribed angle, there are different ways, okay? We can draw an inscribed angle where the chords are on either side of the center of the circle there. Hey guys, is my screen refreshing or no?
No.
It's not refreshing. Okay, so I'm going to do that again. I'm going to stop presenting, and I'm going to do that again. Okay, so
There we go.
So the inscribed angle, okay, which I'm going to call here theta, okay, and this right here, this arc, I want to call that AB, okay. So as it turns out, okay, theta will equal to half of arc AB. Okay, so that's the relationship there, okay. And actually, there are 3 different cases where that can happen. So I can have another circle that looks like this, okay. Well, what if the chords, okay, what if one of the chord was on one side of the center of the circle and the other chord was on the other side of the center of the circle? Would that change anything? As it turns out,
No.
it doesn't.
Wait, haven't we already proved this?
Okay.
I feel like I remember doing
We
this.
did. We did, which is why I asked you guys, do you recall, right? So we did go through this, okay? I'm just reminding you of those cases, okay? And then there was one last case, and that was, well, what happens if if one of the chord actually goes through the center of the circle? What happens in that case then, right? And actually, it doesn't matter, okay? All 3 of these, okay, have the same formula, okay? And this is the inscribed angle formula here. So I am going to box all of this. And again, if you don't remember this, I highly encourage you to write this down or take a screenshot of this, okay? Keep it somewhere, okay? So that's the information, okay? Everyone have this?
Yeah.
Yeah, wait, one sec.
Yes?
Is my
Sure.
video on for everyone? Or is
No, it's not.
yeah, I'm trying to turn it on. I don't remember. That's
I
why keep on
don't see you. No, I don't.
keep on trying to refresh it.
Okay. So everyone have this?
Yep, I have it.
Okay, so I am going to stop presenting here. I'm going to jump back on to this screen. So we're on this right now. Okay, so if you look at this question, okay, by the way that it's stated, okay, we have a circle, center on point B, points A, C, and D lie on the circumference. If angle ABC measures 40 degrees, angle ABC measures 40 degrees, what is angle ADC? Okay, so wait a minute. They're telling us what the inscribed angle is. Okay, we need to know what the central angle is. Wait, what did I say a moment ago? What's the relationship between this arc and and the inscribed angle again?
And he's got
Like the
Half of it.
It's half of it. That's right.
big.
It's half of it. So wait a minute. If this angle here is 40 degrees, and 40 degrees is half of this guy, what will be the angle? What will be the measure for arc AC then?
Well,
It'll be 20.
AC is 40.
Well, think. So one more time. Look. It says that that angle ABC is
No,
40.
ABC.
Angle A.
Yeah, ABC is the center.
Oh, I'm sorry. I misread. So ABC. So that's the central angle. This is 40 degrees. If this is 40 degrees, that means arc AC must be 40. Yes. Again, ABC is 40, so that means arc AC is 40. So therefore, okay, if the inscribed angle is half of this angle, half of this, what must be the inscribed angle then?
It would be 20.
Yeah.
It has to be, okay? It has All right, so let's do that again. So a circle is centered on point B. Points A, C, and D lie on the circumference. Angle ADC measures 62 degrees. ADC measures 62 degrees. So that's this guy down here. Okay, is 62 degrees. What does angle ABC measure? What is the measure of this guy now? Okay. So if this angle here is 62, what has to be the measure of this arc overall then?
Double.
124.
It has to be double it. It's 124. And if this arc is 124, what must be the central angle as a result?
124.
124.
You guys are so good at it. It's 124. You guys are so good.
Ken, quick question. On the
Yeah.
So the assignment yesterday for the video notes said to
Yep.
take notes on 2 videos, but in the calendar there were 3 videos. So what do
Actually, it's
I
3.
send them to?
Yeah, the pacing calendar for the week had 3 videos in there that I want you guys to take notes from.
Oh,
I'll
turned
show it.
into-
I thought there were 6 videos, but there were 3 sets.
Yeah,
No.
yeah. I turned in 2 because it said that on the assignment. Should I go back? I mean, I'm gonna go back and do it. Would you take off points for that?
I'll review it in just a moment. Let's just finish this first, and then I'll talk about that. Okay. So we have angle ADC measures 61 degrees, right?
Mhm.
So again, angle ADC, okay, is this guy right here, is 61 degrees. We want to know what is angle ABC. We want to know what is this angle over here, right? So wait a minute. If this is 61, what has to be the arc? What has to be that angle?
120. 122?
Yeah.
This must be 122. And if this is 122, what must be the central angle then?
122.
It must be 120. You guys are so good. All right. We're almost done. Can you believe that? All right. So we have angle ABC measures 124. So now you're told what the central angle is. Central angle is 124. And now we're asked to find out what is angle ADC.
Wait, what was the answer
This
for the
guy.
previous one?
122.
So one more time. This angle
Giving us
here.
repeats.
Yeah, Emmett's saying that again. It certainly does feel like a repeat. So this angle is 124. So Michael, what has to be this arc?
124.
Good. And the inscribed angle, is it double the arc or is it half of the arc, Ian?
Half of the arc.
Thank you, Michael. So Ian, what would be the angle of this guy right here?
That would be 62.
Would be 62. And Emmett's right. It is like a repeat.
They gotta have more circle problems. Like
Got it.
Okay. All right. So that's that. Let me just go over again just the note-taking assignments that you guys are responsible for this week. So this is the pacing calendar for the week, right? Okay. So right here, okay, there are 2 videos for assignment 1 of 3. Okay. And over here, that's assignment 2 of 3, just one video. And then for assignment 3 of 3, there are 3 videos, these 3. And the reason why I'm putting these 3 together is because they are very, very closely related, which is why I'm having you guys take notes on these 3 together. Okay. Actually, I got this guy. Yeah. So there are 3 videos for assignment 3 of 3.
If you look at the if you look at like third note assignment though, it only has 2 videos, so I got confused and I did 2.
Oh, you know what? Just take notes on this proof right here. Yeah, you should do that because it is stated here over here. My apologies for not writing that.
The second 2 are the ones that were
Say that again.
the second 2 are the ones that were listed.
Yeah. Let me see here. I'll quickly add that on, actually. That really stinks. So we're looking at assignment 3 of 3. Just
That's the week of the 11th.
Oh, that's week of the 11th. Right there. Okay, you're right. It only has 2 listed there.
Yeah, I
Only
put
has
one of
2
them
listed.
instead because that's what it said in the pacing calendar.
You know, I'll leave it there. If you only did 2, that's okay. Because I have a feeling. I have a feeling like the 86 people that submitted that you see here, right? Probably more than likely did that. So if you did that, I'm not gonna.
Maybe you should change the due date to today and add the 3rd video. So then we'll get penalized.
Actually, here I'll help you guys out, right? So I want to show you some of the notes so that you don't have to waste time. Here, I'll do this.
I
I'll do
just
this
draw
right.
whatever he draws on his screen on a piece of paper.
It is. So you know what? You can write down what I'm writing, take a photo of it, and upload it, and that'll be the end of that. You know what I mean? Right? So watch this with me then, okay? I'm gonna do a quick presentation. So that third video there, what does this say? It's supposed to be proof that right triangles.
No, inscribed angles. The proofs were the ones that were there. Those 2 were. Inscribed angles was the one that wasn't on it.
Inscribed angle was the one that wasn't on it.
Yeah, I still watched the video. I just didn't take notes on.
Okay. So you know what? If you upload the this thing, shoot, here. If you upload this, okay, I'll accept that, okay, as part of the notes. Does that make sense?
Yeah.
Okay.
And it doesn't matter if it's.
Say that again.
It doesn't matter if it's turned in late. You'll know what happened.
Right.
All right.
All right, guys. I'm gonna stop recording. Let's see.
Today was a quick.